Hi, my name is Ashok. I'm from FinEx Training Institute. We are providing free classroom training in Mumbai for one entire month for CFA aspirants so that they themselves can decide if they wish to continue this certification. Please feel free to contact us for further details. Thank you. So this video is to explain all these 5 points from the fixed income subject. It talks about change in the annualized rate of return based on the YTM. Okay, so here is the first point: an investor who holds a fixed rate bond to maturity. So that means an investor is holding till maturity will earn an annualized rate of return equal to YTM of the bond. Okay, so this is the first point, and I'm going to derive this one now. I'm going to prove this one with an example. So let's say there is a 10-year bond. 10-year bond coupon is equal to 10 percentage. IY interest rate per year is equal to 8 percentage. Future value is 1000. So in that case, first of all, let's find out what will be the present value. So I'll draw the timeline first, 0 to 10 year. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what will be the present value of this bond? So using BA2 Texas Calci, I'll find out now. So N will be for me, N will be, it's a 10-year bond. So 10 N, IY will be 8 because IY here it is 8. Present value I need to find out. So I'll compute this at the end. Payment will be 10 percentage of 1000 comes to 100, and then the future value will be 1000. So I'll just calculate it now in my calci. 10N, 8IY, 100 payment, 1000 future value, compute present value. So it comes to 1134.20. So 1134.20. So if this is the present value, so what it conveys is what this first point conveys is, if you hold the bond till maturity, your annualized rate of return will be equal to the YTM. Equal to the YTM is this IY is considered as the YTM. So that means annually you are going to get 8 percentage, even though you are getting 10 percentage as the coupon, but finally your annualized rate of return will be 8 percentage. That's what I'm going to prove now. So how is this possible? Let's see. So you are paying 1134.20. This is the present value, and every year you are going to receive 100, 100, 100, 100, 100. So I'm just writing 100 everywhere here, and at the end you will get back the principal amount, which is 1000. Okay, and you are going to hold the bond till maturity. So now what happens is you are going to uh, keep the bond till maturity. So that means you are going to reinvest as well. So when you are going to reinvest, you are going to reinvest at the prevailing interest rate in the market, which is 8 percentage. So you are going to reinvest all these 100, 100, 100. So let's see the future value of all these hundreds. So N, IY, present value, payment, future value. N will be 10 times, you are getting the payment. So IY is you are reinvesting at 8 percentage. So I'm going to write 8 here. Present value is nothing because you want to find the future value of all these hundreds. So payment is 100. So you are going to invest here 100. So I'm doing minus 100. I will get this answer. I need to find out the future value, which I will get it in positive numbers now. So I'll do it now in my calci. 10N, 8IY, then minus 100. So 100 minus payment, and then compute future value. So when I compute future value, I get this as 1448.65. 1448.65. Okay, so this is the future value 1448.65, and also you will get back this 1000. So overall the cash inflow at the end of the 10th year, you will have you need to add these two numbers. So 1000 and 1448 comes to 2448.65, and to earn this 2448.65 you invested 1134.20 at the beginning. Okay, so let me calculate compounded annual growth return, which will give me the annualized rate of return. The formula is closing value divided by opening value to the power 1 by n minus 1. This is how I'm supposed to find out the annualized rate of return. So closing value is 2448.65 and opening value is 1134.20 to the power 1 by, this is for 10 years, so 1 by 10, and then minus 1. So solving this, I will get this 1 by 10 comes as 0.1. So 2448.65 divided by 1134.20 to the power 0.10, and then I do minus 1. So and then I will convert it into percentage, which will give me 8%. This 8% compounded annual growth return is nothing but the IY mentioned at the beginning itself. Mentioned at the beginning itself. Okay. So this is what the first point proves. An investor who holds a fixed rate bond to maturity will earn an annualized rate of return equal to the YTM of the bond when purchased. So this is the derivation of the first point. Now coming to the second one. An investor who sells a bond prior to maturity will earn a rate of return equal to the YTM at purchase if the YTM at sale has not changed since purchase. Fine. So let's prove the second point now. Yeah, let's prove the second point now. So again, I'm taking 10-year bond. Coupon is equal to 10 percentage. IY interest rate in the market is 8 percentage. Future value is equal to 1000. Present value we have already calculated in the first sum. It was 1134.20. So I'm directly taking the number here. Now it's a 10-year bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-year bond. So you invested 1134.20. So you will get 100 each year, and at the end you will get back 1000. Now this second point says an investor who sells a bond prior to maturity will earn a rate of return equal to the YTM at purchase. So YTM at purchase is 8%. So even if you sell the bond prior to maturity, you are going to earn 8% only. This is what this point claims. So prior to maturity, which year? Let's take the example like, let's say I am selling it at the third year, let's say. So if I'm selling it at the third year, still the rate of return that I'm going to get, per annum, annualized rate of return is going to be 8%. So let's prove this point now. So if I'm selling it prior to maturity at the end of the third year, so that means when I'm selling it at the end of the third year, I have received 100. That means here, which I am going to reinvest as well. Okay. So when I'm reinvesting, I will reinvest at the 8%, which is the interest rate in the market. So I need to find out what is the future value of all these 100. So in order to find out the future value of all these 100, so I will use calci again. N, IY, present value, payment, and then future value. N will be 3 because I want to find out the future value of all this 100. IY is 8 because that is the interest rate prevailing in the market. Present value is nothing because I want to find out the future value of all this 100. Payment is going to be minus 100 because I'm investing 100, and so I need to compute now future value. So 3n I'm doing in my calci now, 8 IY, then 100 will be minus payment, compute future value, it comes to 324.64. So I'm going to get 324.64, and then mind you, I'm going to sell this bond as well. So when I sell this bond, what will be the value at which I will sell this bond? That means what is the present value of this bond I need to find out. Now present value of your bond is equal to present value of all its expected future cash flows. So I need to find out the present value of all these future cash flows, all this 100 future, and then this 1000. I need to find out the present value of all these cash flows. So remember this line, present value of a bond is equal to present value of all its expected future cash flows, all its expected future cash flows. Okay, so let me find out the present value here. N IY, present value, payment, and then future value. So N is going to be 1 2 3 1 2 3 4 5 6 7. So 7 times I'm going to get payment of 100, which will be reinvested at 8%. I need to find out the present value. Payment is 100 I'm going to get, and at the end I will get 1000. This 1000 I'm going to get. So if these are the cash flows, what should be the present value? So I'm taking my calci and doing it here. 7n, 8 IY, then 100 payment, 1000 future value, compute present value 1104.12. So this is the present value. So that means I am going to sell the bond at 1104, and at the same time I will also have 324.64 with me. So let me add these two numbers. So when I add these two numbers, I will get 324.64 plus 1104.12. So I will get this number as 324.64 plus 1104.12, 1428. So I will get this number as 1428.76, 1428.76. And how much did I invest? I invested 1134.20. So invested amount 1134.20. So CAGR, compounded annual growth return, is equal to closing value is 1428.76 divided by 1134.20. Okay, so to the power 1 by 3 minus 1. So equal to, so 1 by 3 is 0.3333. So 1428.76 divided by 1134.20 to the power 0.3333. So, and then minus 1. So when I convert it into percentage, I get 8%, which is equal to the initial YTM. So equal to the initial YTM. So this proves the second statement. This proves the second statement. So an investor who sells a bond prior to maturity will earn a rate of return equal to the YTM at purchase if the YTM at sale has not changed since purchase. Okay, so YTM is not changing, right? So this is to prove the second point. Then the third one is, if the market YTM for the bond, our assumed reinvestment rate, increases after the bond is purchased but before the first coupon date. Okay, so before the first coupon date it increases. A buy and hold investors realized return will be higher than the YTM of the bond when purchased. Okay, so buy and hold. So let's say you are holding it till maturity. So in that case, your returns will be higher than the YTM of the bond when purchased. So let's prove this point now. So third point. So third point, in order to prove the third point, let's do one more sum. So 10-year bond, 10-year bond, coupon is equal to 10 percentage, IY is equal to 8 percentage, future value is 1000 and present value is 1134.20. Okay, so again this we did it in the first sum itself, we calculated this present value. So now I'll draw the timeline 0 to 10 years. So 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. So initially you are going to spend 1134.20. Then every time you are going to get 10 percentage of 1000, that is 100, 100, and then at the end you will get back your 1000. So these are the cash flows. Now um, so third point says our assumed reinvestment rate increases after the bond is purchased but before the first coupon date. Okay, so that means new IY over here increases. So let's keep the new IY as, let's say, 9 percentage. So new IY is equal to 9 percentage. So this IY gets changed to 9 percentage. So if that is the case, then how will be the annualized rate of return impacted? How will it result into? So that's what we need to see. So logically also you can think and then find it out. What happens logically, you think like all these 100 you are going to reinvest. So you are going to reinvest at the 9 percentage because that is the prevailing interest rate in the market. So when you are reinvesting all these 100 at 9 percentage, so obviously you are going to get more rate of return because initially you are supposed to reinvest only at 8 percentage, but because the new IY is 9 percentage, you will reinvest at 9 percentage, and so your overall return will be more than the initial IY. So your overall return will be more than 8 percentage. Okay, so logically also you can think, and also let's derive this mathematically as well. So now I'm going to reinvest this at the rate of 9 percentage. Okay, and I'm going to keep it till maturity because it says yeah, buy and hold investors realized return will be higher. So I'm going to buy and hold it. So when I'm going to buy and hold it till maturity, what will happen? So first of all, what is the future value of all these 100? So future value of all these 100, N, IY, present value, payment, and then future value. N will be 10. 10 times I am going to get this 100, and it will be reinvested at 9 percentage. Present value is nothing because I need to find out the future value of all this 100. So 100 minus, because I am going to invest 100. So minus 100. Now I'll find out the future value. 10 N, 9 IY, 100 minus payment, compute future value. It comes to 1519.29. So this is the future value of all the hundreds that I'm going to get, 1519, and also I'm going to get this 1000 as well. So overall you have to add these two amount. So overall I will have 1000, this 1000 and 1519. So overall I will have 2519.29, and I invested 1134.20. Okay, so annualized rate of return, compounded annual growth return, is equal to 2519.29 divided by 1134.20. Now this is for 10 years. So 1 by 10 minus 1. So 1 by 10 is 0.1. Now 2519.29 divided by 1134.20, then y raised to x 0.1, then minus 1. So I'm getting 8.3 percentage. When I convert it into percentage, 8.30 percentage, which is higher than the initial 8 percentage. Okay, so this is what proves the third point. It is higher than the initial IY. This was the initial IY. Okay, and this is the rate of return that I am getting. Why am I getting higher rate? Because it was reinvested at the higher rate for a long period of time. Okay, so this proves the third point. Now here, what if the interest rate comes down? Okay, so if the interest rate comes down, the returns will be lower. Okay, so again that is logical because I'm going to reinvest at the lower rate. If lower rate, see here in this case what happens is interest rate has gone up. What if interest rate has gone down from 8 to let's say 7 percentage? Then I would have reinvested all at the lower rate, and so my overall return will be less than 8 percentage. So if I have to prove that, so let me prove that as well. So if the interest rate comes down to 7 percentage, so 1 2 3 4 5 6 7 8 9 10. Now 1134.20 is what I'm going to invest, and I'm supposed to get every time 100, 100, and then 1000 at the end. Now here the interest rate comes down to 7 percentage. So instead of 8, it has come down to 7. So now I am going to reinvest all this at 7 percentage, and so my returns will be lower than the initial IY of 8 percentage. Let's see how. So NIY, present value, payment, and then future value. So N was 10 times. I'm going to reinvest at 7 percentage. Present value is nothing because I need to find out the future value of all this payment. Payment is minus 100. So compute future value. So compute future value 10 N 7 IY 100 minus 100 payment. Compute future value. I get here 1381.6, 1381.64. So this is the future value, and also I will have 1000 with me. So I need to add these two amount. So when I add, I will get 2381.64, and I invested 1134.20. So my CAGR is going to be 2381.64 divided by 1134.20 to the power 1 by 10 minus 1. So when I calculate, so 1 by 10 will be 0.10. So 2381.64 divided by 1134.20, then y raised to x 0.10 minus 1. So I convert it into percentage. I am getting 7.7 percentage only, which is lower than 8 percentage. 7.7 percentage is lower than my initial IY of 8 percentage. So that's what proves this third point about decrease in the IY. When IY decreases and I'm following the strategy of buy and hold, so my return will be lower than the YTM of the bond when purchased. So when it was purchased, it was 8 percentage. Now it is 7.7 percentage. So this proves the third point. Then fourth one, if the market YTM for the bond, our assumed reinvestment rate increases after the bond is purchased, but before the first coupon date, a bond investor will earn a rate of return that is lower than the YTM at bond purchase if the bond is held for a short period. Now this is quite counterintuitive, so this needs more attention. You see here the interest rate is going up. Now when the interest rate is going up, still your returns will be lower than the YTM. Okay, interest rate is going up, so you are reinvesting at the higher rate only, but still your overall return, annual return, will be lower than the YTM if it is held for short period. Okay, if it is held for short period, it will be lower. So when the interest is going up, how come the annualized rate of return is lower? That's what we are going to see now. So fourth point, yeah. So now again I'm taking 10-year bond, 10 year 10-year bond, coupon is equal to 10 percentage. Let's say IY is 8 percentage, uh, future value is 1000, present value 1134.20. So now interest rate increases after the bond is purchased. Okay, so now let me draw the timeline. 0, 5, 10, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1134.20, and then 100, 100. So I'm going to get 100. Yeah. So these are the cash flows. Now my interest rate is going up. Okay, interest rate increases. So new IY is 9 percentage. New IY is 9 percentage. So I'm going to reinvest at 9 percentage. However, even though I'm reinvesting at the higher rate, my overall return is going to come down if I'm holding it for short period. So short period as in, let's say this 3 years only now. So I'm going to hold it only for 3 years. So at the end of the third year, how much return I must have earned? That's what I'm going to check now. So because I'm going to hold it only for 3 years, so only these amount I'm going to reinvest, these payments. So let's find out the future value of all these hundreds. So N, IY, present value, payment, future value. So N is 1, 2, 3, 3 times I'm getting 100. So 3. IY is 9 percentage. So 9. Present value, present value, nothing. Payment 100 I'm going to reinvest. I need to find out the future value of this 100. So 3N, 9 IY, and then payment 100 minus payment. Compute future value. It comes to 327.81. So 327.81. So this is one cash flow that I'm going to get, 327.81. But I also have to find out the present value of the bond. So at what rate will I sell this bond? So when I sell, I will also get some cash, right? So present value of your bond is equal to present value of all its expected future cash flows. So how do I find out now? How do I find out the present value of all these future cash flows so that I get the present value of the bond? So in order to find out this, again N, IY, present value, payment, and then future value. N will be, now this time 1, 2, 3, 4, 5, 6, 7 times. So 7. IY is, it will be reinvested at 9 percentage, 9 percentage, and then 9 percentage. Present value is what I need to find out, and then payment, uh, payment payment is 100, and then future value is 1000. Okay, so 7N and IY will be 9. So IY is the new rate of interest, 9 percentage is the new rate of interest, 9 percentage. Okay, so now when I key in all these numbers into the system, let's see what is the present value of the bond. So 7N, 9IY, 100 payment, 1000 future value, compute present value 1050. It comes to 1050.32, 1050.32 and 32781. So these two are the cash I'm going to have. So add these two. So I will get 1050.32 plus 327.81. So 1378.13, and initially I invested 1134.20. So my CAGR will be 1378.13 divided by 1134.20. Now for how long did I invest? I invested it for 3 years. So because it is for 3 years, so 1 by 3 minus 1. Okay, so mind you, this time even though the interest rate has gone up, my return should be lower than 8%. So let's check that one. So 1 by 3 is first of all 0.3333. So 1378.13 divided by 1134.20 to the power 0.33333, then minus 1. So I get 6.7 percentage. 6.7 percentage, which is lower than the initial IY of 8 percentage. Okay, so this is what the fourth point uh, proves. So for a short period when I hold, my returns are going down when the interest rate in the market is going up. So this is what I have proved it mathematically. But logically, let's try to understand how does it fit in now logically. See, now when the interest rate in the market is going up, which is good. So see, now when you are investing, your investment is exposed to reinvestment risk and market price risk. Market price means bond price risk. Bond price risk. Now when you are investing, when you are reinvesting at 9 percentage. So you are reinvesting at 9 percentage, which is good. However, you are not able to take advantage of this for a long period of time because you are investing for short period. So the benefit that you are getting is only for short period. So benefit is for short period. So reinvestment risk is favoring you, but it is only for short period. And also remember that when the interest rate in the market goes up, bond price comes down. So bond price is coming down, it holds inverse relationship, right? So when I'm finding the present value of the bond price comes down heavily, because this time when I was finding the present value of this bond, I was using the discount rate 9 percentage instead of 8 percentage. So when I'm using 9 percentage, the bond price comes down heavily. So that's why it has come down to 1050. So here it is a very big impact. The bond price comes down heavily to 1050. So because it comes down heavily to 1050, it is coming down heavily to 1050, and so that's why my overall cash flow is 1378. So 1378, when I use over here, my returns are lower. Okay, so that means the market price risk is playing a big role over here, which is against me. So this market price risk is against me because when the interest rate went up, bond price came down. So my investment is exposed to market price risk, and that happened for a long period of time. Okay, that happened for a long period of time. So 1, 2, 3, 4, 5, 6, 7, for 7 years, and that's the reason the price of the bond has come down heavily, and so overall my return has come down. Okay, so this is the proof for the fourth period. Now suppose instead of increase, suppose if the interest rate comes down, then let's see what happens. So in that case, then what will happen? So okay, so let me try that over here. interest rate instead of increase, because this point says increase. Now imagine for a short period only you are holding and the interest rate comes down, then how will it impact? See, now 0 to 10 years 3, so I'm investing 100 and here also 100, and my new IY is, let's say, initial IY was 8 percentage, correct, and new IY is 7 percentage, 7 percentage. So somewhere over here new IY became 7 percentage. So when it became 7 percentage, I'm reinvesting at 7 percentage. Okay, so what is the future cash flow of these hundreds? N IY, present value, payment, future value. So N is going to be 3 times, and IY is 7 percentage. So 7, present value is nothing, payment is 100 minus, and so future value I need to find out now. So 3N, 7 IY, 100 payment minus compute future value, it comes to 321.49. And also I'm going to sell this bond at the end of the third year. So from fourth, so fourth, fifth, sixth, seventh, eighth, ninth, 10th. So each time I'm supposed to receive here 100. So the present value of this bond over here will be equal to present value of all these expected future cash flows. So how will I find out the present value of the bond? So in order to find out the present value of the bond, so again N IY, present value, payment, future value. So N is going to be 1 2 3 4 5 6 7 times. IY is, IY will be 7 percentage, right? Because this is the new IY, 7 percentage, new IY 7 percentage. So 7, present value I need to find out. So I need to find out the present value. Payment is 100 and future value is 1000. So let me key in all these details into the calci. So 7N, 7 IY, 100 payment, 1000 future value, compute present value, it comes to 1161.6. So overall I will have this much of cash at the end of the third year, 1161.6 plus 321.49. So 1483.09, and 1134.20 is what we invested. So CAGR is equal to 1483.09 divided by 1134.20. Now this is for 3 years only, so 1 by 3 minus 1. So let's calculate this one. 1483.09 divided by 1134.20 to the power 0.33333. So minus 1. So I get 9.35 percentage. So 9.35 percentage, which is far ahead of 8 percentage, way ahead of 8 percentage. Okay, so why is this happening? Again, your investment is exposed to reinvestment risk and market price risk. Now you are reinvesting for short period of time. Okay, so for short period of time, interest rate has come down. Now when interest rate has come down, so reinvestment risk is not favoring you. So you are getting only 7 percentage. However, market price risk is more powerful over here. How? Because when the interest rate is coming down to 7 percentage, bond price goes up highly, because 7 years are pending, 7 years are pending. And so for 7 years, when you are finding the present value, so the present value goes up highly, it goes to 1161.09. 6. So market price risk is more powerful over here. Market price risk, and market price risk is favoring you. So market price risk is favoring you, and so the price has gone up highly to 1161, and so overall it comes to 14883, and so you are getting 9.35 percentage, which is way ahead of 8 percentage, right? So this proves the fourth point as well. Now coming to the fifth point. Fifth point is simpler. If the market YTM for the bond, our assumed reinvestment rate decreases after the bond is purchased. But before the first coupon date, your bond investor will earn a rate of return that is lower than the YTM. So here IY is also decreasing and you are getting lower YTM. So it is very intuitive. In the long run or for a long period, you are going to hold this bond. So let me prove this one. It's easier. So fifth point. So again, I'm just writing directly here. 10-year bond, 10-year, and initially it was 1134.20. So 1 2 3 4 5 6 7 8 9 10. So each year 100, and then um, reinvested will earn your rate of return lower. Okay, so here the interest rate is coming down. So let's say new IY is 7 percentage. Okay, so initial IY was 8 percentage and new IY is 7 percentage. So this is the new IY. New IY is 7 percentage. New IY is 7 percentage. Yeah. So now if the market YTM for the bond, our assumed reinvestment rate decreases after the bond is purchased but before the first coupon date. That means over here before the first coupon, a bond investor will earn a rate of return that is lower than the YTM at bond purchase if the bond is held for a long period. So held for a long period, so let's say 9 years. So you are holding this bond for 9 years. So when you are holding for 9 years, you have to find out for these 9 years what is the future cash flow of all these payments that you are receiving first of all. So that is NIY, present value, payment, future value. So N is 9, IY is you are reinvesting at 7 percentage, present value is nothing, payment is 100 minus, so what is the future value? So 9 N 7 IY minus 100 payment, so compute future value, it comes to 1197.79. 1197.79. And what is the present value of the bond over here? So present value of the bond is equal to present value of all its expected future cash flows. So expected future cash flows is only this part. So NIY, present value, payment, future value, N is equal to only one uh, is remaining here, one period of payment. IY is 7, present value we have to find out, present value, payment is 100 I am going to receive, and future value is 1000. So what is the present value here? So 1 N 7 IY, payment is 100, 1000 is the future value, compute present value. So it goes to 1028.03. 1028.03. So that means I am going to have 1197 and 1028.03. So adding these two numbers, Adding these two numbers, I will get 1197.79 plus 1028.03. So I will get 2225.82 and I invested 1134.20. So compounded annual growth rate is equal to 2225.82 divided by 1134.20. Now to the power 1 by 9 minus 1. So 1 by 9 comes to 0.1111. Okay. So now 2225.82 divided by 1134.20. Y raised to x, recall 1, 0.1111. And then I will do minus 1. So when I calculate all this, I get 7.77 percentage. 7.77 percentage. So now 7.77 percentage is lower than the initial IY of 8 percentage. So my interest rate came down. Okay, interest rate came down to 7 percentage. So and I reinvested for a long period at 7 percentage. So in this case, again, reinvestment risk and bond price risk. If I talk about this bond price risk, so reinvestment risk is more powerful in this case because I'm holding it for a long period of time, and reinvestment risk is against me because I'm able to reinvest at 7 percentage. So this is more powerful and it is against me. So because it is against me and that is more powerful, and so overall my return is lower than the initial IY. Okay, so this proves the fifth point as well. Hope this is fine for you all. I feel like, very important one, all these 5 points. Yeah, thank you so much for your time.